Welcome to the next topic, topic N, Diophantine equations. This one's kind of exciting and for newer students a little bit challenging, but after a few examples, hopefully it won't be too bad. All right, the first video, N1, is just an introduction to linear Diophantine equations, and then the next videos will have some examples where we solve problems. All right, first of all, what is a linear Diophantine equation? It's an equation of this form, ax plus by equals c, where the solutions x comma y, are integers. Hence, that's what makes it in the number theory subset. All right, Diophantus of Alexandria, he lived from 200 to 284 AD. Sometimes he's referred to as the father of algebra, and he studied these types of equations, hence the name. All right, first of all, these Diophantine linear equations are solvable if and only if, you'll find in later math classes, IFF stands for that, if and only if the greatest common divisor of A and B divides C. And I'll give you an example. I'll write it here and then erase it. So, for example, let's say we've got the equation 3x plus 6y equals 4. And we want to find integer solutions. Of course it's got solutions, it's a line, but we want to see if it's got integer solutions. All right, so we're going to take the greatest common divisor of 3 and 6. So the greatest common divisor of 3 and 6, I could do that in my head, is 3. However, 3 does not divide 4. When we say does 3 divide 4, we mean is 4 a multiple of 3, basically. And the answer is no. Therefore, those 3 dots mean therefore, there are no integer solutions. Okay, if there are solutions, there will be infinitely many. And so let's talk about that now. All right, so the general form of the solutions. Let's start with an equation of this form. Ax plus by equals 1. The general solution, first let me talk about the specific solutions. So I'll just do that here. Specific solution. Because when we do this process, we're going to first find a specific solution. So we'll call the specific solution x naught, y naught. Then the general solutions will be as follows. X equals that specific solution plus b times n, where n is any integer. And then y will be, take a guess, y naught, however in this case, minus an. And again, I'll emphasize where n is any integer, positive, negative, or 0. Okay, so this is very important to understand this. When we're solving these problems, we'll be using the Euclidean algorithm and also the Euclidean algorithm in reverse. So this is often called the extended Euclidean algorithm. And then finally, we talked about the Euclidean algorithm in videos E1 through E4. So you may want to review those because we're going to build upon that. So there you have it, an introduction to Diophantine equations.